Okay, we will get started. So welcome everyone to the webinar on energy perspectives in CEA. The purpose of this webinar is to provide insights on CEA energy considerations on operations, industry, and academia. I will explain a bit about the process, where we will discuss some relevant topics regarding energy in CEA, and then we will follow with a Q&A session. You can send the questions via the Q&A tool throughout the webinar, and we will answer them at the end. If we don't manage to answer all the questions today, we will address them on Agritecture's bi-weekly newsletter. So allow me to introduce myself. My name is Alberto Lopez, Systems Engineer at Agritecture, and I will be the moderator today. As part of the technical team at Agritecture, I advise clients on optimization of operations and energy performance of CEA facilities. Joining us today is Herve Maumus-Hue, engineer at Ceres Greenhouse Solutions. Herve, can you tell us a bit about your work?
Yes, thank you, Alberto. So I work for Ceres Greenhouse Solutions for more than 2 years now. I learned everything about greenhouses with this company, and I work as an engineer for Ceres. Basically, my work is dedicated to make our clients' greenhouses more efficient, even our future designs more efficient through innovative design, equipment type, how to control this equipment, and to reach the goals of our clients, which is usually grow optimally for less money. So we are dedicated to use less energy for like a lower footprint in general. So that's my daily work at Ceres.
Perfect. And now we have Gene Giacomelli, professor and former director of the Control Environment Agricultural Center at the University of Arizona. Gene, welcome.
Thank you. It's a pleasure to be here. Thank you very much for the opportunity. Yeah, my name is Gene Giacomelli. I'm a professor at the University of Arizona in the Biosystems Engineering Department. I spent all of my time, however, at the Controlled Environment Agriculture Center here in Tucson, Arizona. My career has been in greenhouse engineering and climate control and some automation, anything to do with production systems growing inside controlled environments, primarily with the focus on greenhouse, but more recently with fully enclosed, artificially lighted structures as well. My expertise really falls in the crop production. I have a horticultural background as well as an engineering background, and I enjoy putting systems together that produce crops the way we want them to be produced and when we want them to be produced and at a given quality. I look forward to our discussions today. Thank you.
Perfect. Thank you very much. Now we have Mark Essam, founder and CEO at YASAI. Mark, tell us a bit about YASAI.
Good evening to the people in Asia and Europe, and good morning, afternoon to the Americas. Thank you very much for having me. I'm the co-founder and CEO of YASAI. We focus on vertical farming as a service based on circular systems. And therefore, we are actually looking at reducing the energy demand for vertical farming tremendously by applying circular systems. And this is what we are here for, and I'm glad that we can talk about it today. Thank you.
Very interesting. So I will start as a bit of introduction. We should consider that a CEA operation is a complex biological system, and the resources, energy, water, CO2, are impacted on many things such as the crop, local climate, market, which means that there is no standard solution. The main purpose of a CEA operation is to create suitable conditions for the crop production. To achieve this controlled environment, there are different options currently available. So now we will talk briefly about the current technologies available for heating, cooling, humidity, and light control. Hervé, if you can tell us a bit about the current available technologies from the greenhouse side.
Yeah, for sure. So what I think there is like a wide range of different technologies available. It goes from the simplest ones like a hoop house with just a glazing and plants in the soil without any equipment that can give a crop for like when the outside conditions are kind enough. And it goes up to like sealed greenhouse systems. Like we design sealed greenhouse systems that are usually used for high value crops because of the upfront cost of the greenhouse and the equipment inside. But the range of control and quality of the crop is highly improved. And between those two extremes, there are like a million of different possibilities. In North America, in northern locations, we usually see like greenhouses with at least a heater for maintaining the crops alive during winter. With sometimes evaporative cooling in dry locations for cooling in the summer, same for like just keeping the crops alive. And then you can go with like more complex or more simple equipment. But as I said before, it can take like a lot of time to describe all of different options, but that gives like an idea of the spectrum of the technologies.
Perfect. Mark, from the vertical farming side or from the indoor farming, what type of technologies are currently available?
So we apply highly automated technologies in terms of internal logistics, but also in terms of software solutions, and also regarding biotech. So the biggest plus, I would say, of indoor vertical farming is that we can actually control every parameter, which offers us to also get into really detailed systems, whether it's creating the best environment for the substrate or the plant itself, but also the climate. And then you can start to integrate this system, these highly densified systems, into the urban fabric. Therefore, we focus on contexts which are usually import countries of fruits and vegetables, and countries with a lack of arable land or freshwater resources. And I think that's where vertical farming is at its best right now.
Okay, so based on the technologies mentioned, and this is just a question for the three of you, do you think in general, the industry stakeholders, or we're calling operators, suppliers, they have a good grasp of the importance of energy use when it comes to equipment selection? So is it a big, let's say, aspect when it comes to equipment selection?
So if you think about vertical farming, the energy use is by far the largest cost factor. And therefore, it is crucial that we create synergies to reuse energy. For example, we reuse the heat that is produced by our LEDs to heat up neighboring spaces. And like this, we can reduce the energy costs from a whole area or district. But this only works if you can create synergies between different spaces and uses. So I don't think vertical farming in a very, very large scale applied like in the Netherlands with greenhouses would make so much sense, to be honest. But that's just one perspective.
I think it has a lot to do with the expertise, the experience that the grower, the operator, the developer of the production facility has. If there is a lot of historical experience with greenhouse, then there is an understanding that you put a greenhouse in a location and your goal is to offset the environmental conditions of nature to meet the needs of the plant. And if you put it in a cold place, you know you're going to be heating a lot. You put it in a warmer place, you're going to be cooling a lot. But you're going to be doing both at some level all the time. That's just the nature of the greenhouse, using solar energy, the sun, for providing the energy for plant growth and the warmth that will raise the temperature in the greenhouse, and then your need to cool during the day and heat during the night. So it becomes an operations challenge, and I hope we'll get to that a little bit later. But then if you look to vertical farms, they, or insulated structures, whatever you want to call them, they are controlled environments that are much more separated or insulated from the local environment. They are more concentrated, they have a smaller footprint, so they can go in many more locations than even a greenhouse, and certainly an open field farm. It's been a nice transition to see from open field to greenhouse, relatively concentrated, to indoor structures like vertical farms that are super concentrated and are right at the site where the production can be provided to the community. So it becomes then an understanding of, what do I have to deal with environmentally? Then what do I have to deal with materials moving in and out, and the labor to do that? And in many ways they can be similar, a greenhouse and a vertical farm, and in many ways they may not be, depending on the design.
And
Yeah.
I would like to add something. Sorry, Alberto, can you hear me well? I've got some issues with my internet. Can you hear me well?
Yeah, we can hear you. Go ahead, Herve.
No, okay, sorry. I've got issues with my internet. You can go ahead, sorry.
No, what I was going to ask was, yeah, now we understand that from the, let's say, the importance of the integration from the vertical farm perspective, integration, and then this energy, how to call them, a nexus that you need to have because of the, let's say, high energy demand. I want to ask, do you, and to all the panel, have you heard false or imprecise statements in the industry when it relates to energy use? Like, for example, I remember, like, I come from Costa Rica. I remember there was a supplier saying that basically you can grow whatever you want in a greenhouse, and independent of whatever the external conditions are. We realize it's not true, but I want to hear, have you heard certain comments, statements around the industry about it?
So if I may add something, there's a lot of marketing going on, and I think the real life cycle assessments still need to be proved for various contexts, because each context will be different. And to be honest, I don't think it's either vertical farming or greenhouses. It will be complementary at some point, and also regarding to the products that can be grown. So it doesn't make sense, for instance, to grow large tomatoes in a vertical farming system just because of the height of the system itself, because you can stack it up, and tomatoes require quite a height to grow, which then doesn't make it interesting anymore economically. So I think there are many claims right now, especially in vertical farming, because it's a new industry. It is developing itself. It's still growing itself. And I think this is also perhaps the reason why there's not enough scientific life cycle assessments, which actually prove which products make sense for which context in which systems. So that's what I would say.
Yeah, agreed. It's too early in the availability of vertical farms. I mean, LEDs became available at a lower cost, lighting became more efficient, and they took off. Indoor growing, get rid of the sun, insulate the building. I'll have more easily ability to control the environment. But your life cycle assessment is one aspect, but even at a lower intensity level of evaluation is just to look at what is productivity, not just per unit area, but per unit input of electrical power, of heating fuel if you're in a greenhouse, or how about labor, water use as well, and nutrition. So all of these things can be looked at as individual factors which provide metrics to give you an idea of how efficient or inefficient you may be relative to other systems, and how you can look to improve under your particular growing system and environmental control system. Obviously, the first challenge of the vertical farms, and I'm saying that 10, 11, 12 years is all that they've been available, and in large proportions, and a lot of people going into it. Obviously, there were some in the past. But so we're learning that immediately that it's electrical power becomes the challenge because of lighting. You're eliminating the sun, and you're using electric power to have better control and better light quality control, with the potential for producing better quality plants. But there's a lot to learn about lighting, and there is a lot of research going on right now, and it will be for the next probably decade or two to find out what's the most optimum lighting conditions. Now, traditional engineering can bring in immediately the challenges of cooling and dehumidifying, because what happens in an insulated building when you put electrical power inside, and not all that electrical power becomes light. A lot of it becomes heat, and you have to distribute that. Plus, you have the plants that are transpiring and putting latent energy, moisture into the air that you have to then reduce to maintain the quality environmental control for good, healthy plants that are not disease infested, so to speak. So then the HVAC, or the environmental control, also electrically powered, needs to be the next big consideration. And then, oh, by the way, you have to have labor taking care of the plants, moving them around. A good design of a production system, a growing system that's put inside of an environmental control system, whether it's a greenhouse or a vertical farm, makes efficient use of labor. It minimizes it, and it utilizes it efficiently, meaning every movement, every activity is well understood and scoped out and organized, so that labor, it's going to be there unless you have full automation. And there are some plants, maybe the lettuces and some greens, where you can get full automation. But anything beyond that at this point, I believe that you still need significant labor to care from seeding through to harvest, and even post-harvest. So electric power for lighting, electric power for HVAC and environmental control, cooling and dehumidifying, and then labor costs. So if you put this in a location such as I'm in, and where California is right now with severe water shortages, then the vertical farm, with fully closed, the ability to capture not only the irrigation water to the plants and reuse it, but capture the moisture that the plants give off in transpiring, to really have a closed water loop system. In a greenhouse, that can be done too, at least at the root zone and the hydroponic system, to recycle the water, and that's been traditionally done, or drain the waste as well has been done a lot, of course, too. But it's hard to capture the transpiration water in a greenhouse, because you're ventilating the air inside with exhaust fans, bringing in outside air and dumping out your hot, moist air. In the vertical farm, you don't dump that. You cool it, dehumidify, condense the water out, and then you can reuse it. So there's some options that you have in these different systems. And it's not just all environmental control and labor and energy that I just said, it's also market and the value of the product you have that comes out of that system and what you can sell it for. And by the way, Alberto, I have to disagree with the fact that you can grow anything you want in a controlled environment. Anything, any plant, no matter how big it is. The challenge is, can you make a profit from growing that plant? And that's where you have to look at it. Keep in mind that we're developing systems, as others are around the country and the world, to put growing systems together for another planet, growing on Mars for feeding people. So you can grow anywhere, anytime, any crop, if you have the funds to put together and you have a cost-benefit relationship that makes sense.
Yeah,
I completely agree at this comment of Gene. So
yeah, makes sense, and we understand that let's say, yeah, the definition of optimal, right? So optimal is the good use, the efficient use of resources. So now we have here a bit of distribution of the costs of a glass house in, I think this was in Netherlands, and in an industrial vertical farm in Berlin. So I want to hear from the panel, what are the factors? Well, we heard a bit what Gene just said, but just to really pinpoint, what are the factors that affect the energy use, either for greenhouses and vertical farms? So we heard a bit about the weather, the control strategies, set points. What will be key factors, and where can we decrease, let's say, the costs of energy or the actual energy use in this CEA projects?
I think Gene said almost everything, like laid out the equation of the entire challenge, that is how to grow more optimally for less cost, and how do we define each pieces of this equation. I think we can bring something also about like what seems to be more and more coming into the CA world, like greenhouses or indoor farming, is the control strategies. How smart of a control you have, and how can you have a synergy between your equipment and the plants. So like we talked about like closed designs, indoor farming, like you have everything under control with what you can control the entire environment inside. But a greenhouse can also apply to that, because you need to consider the light intensity at each day of the year. That will impact the transpiration of the plant. So if you have like equipment that can react to or can predict the difference in weather and light intensity, and you can already make like some gain in efficiency. You can have potentially your exhaust fans that will run in low speed or higher speed, your shade cloth that will come like 30 minutes before there is like a strong sun peak when you already reach the DLI target. These kind of strategies can be implemented. It's a lot of software development right now, and that's very challenging, but we can make a lot of energy savings thanks to that.
I would add to that, Herve, spot on in the mark there with what you're saying about software. But let's take a step back and say there's the sensors that are monitoring the environment that have improved in quality and lower cost and capabilities, that can feed the computer and the software now the information that it needs, so that the evaluation can be done and smarter decisions can be made, because the control system now knows much more than it did 30 or 40 years ago, when it could just measure air temperature and relative humidity, rarely even measuring light intensity. So now light intensity is included in carbon dioxide concentration, and there's a weather station, and and the ability to predict the future weather and compensate for that in your control of your heating system or prepare your cooling system. So I would emphasize that a good control system has the software to do the analysis, and that is in great development right now to do more elaborate analysis. But it's based on the fact that it could measure good sensor and environment about the plant, which brings us to, I know I'm not supposed to talk about this yet, but the future is that we should be, and the industry is beginning to monitor the plant more directly than it ever has before. And the plant-based environmental control information that can give idea of the stress or lack of stress or the health of the plant in the long term, as it is today, but as its trajectory is going towards maturity, that it's on track, that the plant model is measuring, is being compared, and it's correct. So this would be something that will continue to give us much more information about the plant itself and less about the environment that it's sitting in, the greenhouse, the bulk mean air temperature and relative humidity. It's more important knowing the plant's temperature, the plant's photosynthetic rate, the plant's use of water rate, and all these things will improve and make more efficient production in terms of quality of the plant and yield, I hope, as well as reduce, I would expect, resource needs to grow that plant.
And
Absolutely.
as well as the LED market, like the first LEDs or any new technology that comes around is very expensive for the first time. Yep. And gets less and less expensive the more people start to be educated to these systems. And the sensors right now, we have like a wide variety of research sensors can be applied in facilities, but they are quite expensive. But we have we need to educate people to have these sensors because we can give guidelines on what you should measure, but then you need to have the budget for it, and that's like stakeholders that will at the end decide. Like I'm happy with a temperature and relative humidity sensor in the middle of my greenhouse, and that will be enough. And you have to convince people that actually you can probably grow way better crop for less energy if you can actually understand the plants with, like you mentioned, like plant temperature, like leaf temperature sensors, stem diameter sensors, stomatal conductance, like having like a plant science background into an environment like this can bring a lot of efficiency and consistency in terms of crop and yields. Sorry, Alberto, I quoted you.
What we also observe in Switzerland is the knowledge and information along the whole supply chain is there's much more information available, and which enables at the end to make the whole system leaner. So instead of just looking at the production system, perhaps we should create life cycle assessments for the whole supply chain system of from the production until the customer actually will consume it. So this is something that we can observe right now, and I think this is also of great value, because at some point then we can go away from a supply system to an on-demand system, so people can actually start telling directly what I want to demand or to buy or to consume, and then you would have it grown on demand and not on supply. So the food waste itself is reduced drastically, perhaps.
That's a very good point. We've been focusing, or certainly I've been focusing on inside the production facility, but there's all the resources needed prior to getting to that facility, and then there's the post-harvest and getting it to the people to consume. All of that has energy considerations, materials, waste stream considerations as well. I would be a little concerned about on demand though, because I like to have a little buffer in my food storage systems around the world, and because my buffer in my stomach is too small, it only lasts a couple hours, but we may need something that lasts a few days to a few weeks for fresh vegetables or fresh products that are perishable. And then of course we want to have months on end for the storage of the grain crops, which is again a different story. If I could continue, Alberto, with sensors and controls, the beauty of sensors is it gives us more information. The challenge of sensors is that we need to know what to do with that information. And I think, Herve, that's what scares growers at times. It's not only the dollar signs that go along with monitoring for a better control system, but is how does my control system help me if I don't understand how the plant, what is the plant telling me? And that's going to be a new generation. There's existing generation, of course, that are very good. The green thumb people have the vision and the experience. But if you come in without that experience, you need the science background, the plant science background, and some engineering and sensor capabilities to understand your situation. And then you need to make good decisions with that information. What do I do with this in this morning after I've seen a difficult night for my plants, and the day before was relatively cloudy and dark and cold, and now the sun is coming out really strong today. And so how do I modify my environment? It should be different for that plant today than it was yesterday. And then if we can have the sensors telling us that the plant is responding positively to my changes in real time, not having to wait for a graph to come back or a consultant to tell me a week later, I want to know right now. And that's still a challenge.
Yeah, I agree. And some of this challenge, I think, doesn't require the grower to really worry about it. If you have like the capacity of and the skill set to develop like smart algorithms that actually understand the plant science and input already the how to react, how your equipment should react to these prior days or to the next days. I mean, what I'm saying right now might seem totally crazy, and maybe in 20 years we will touch the. But I think we see this trend of trying to improve in that sense without necessarily like having a consultant that stays in your greenhouse every day with sensors, handheld sensors that will not make sense. Like nobody can afford to pay plant scientists a work time, but hopefully with sensors and implementation of data analysis already built in the algorithm that control the equipment, we might go to the right way and make this improvement.
Agreed. That needs to be developed. The question is how long. I hope it's sooner rather than later.
I added the link of vivon.ch. That's a startup from Geneva, and what they do, I'm overwhelmed with what they are capable to do. So they can actually listen to the plant and know through their biosignals, through the water, what they communicate to each other. And this helps us to actually understand what the plants want. And at some point, we could actually replicate these signals and frequencies and talk to them. So I think these guys are doing, this is just one example of plant science, which I think I would like to highlight at this point. Yeah, but thank you.
Very well. Just to recap, we've been through the current technologies from greenhouses and vertical farms. So what we're doing to heating, cooling, and other types of technologies. Then we went through, Gene gave us a nice breakdown of what are the most or the factors that incur in costs in the energy use, and yeah, basically all the aspects of a CEA operation. And we had just had a really nice discussion on the future trends and developments. And yeah, my takeaway is we're in the verge of let's say a shift in how we assess data, how we monitor data, and how we acquire data. Now we're not focusing more on set points, environmental set points, but now we're going through what that plan actually needs. So at the end, well, for me, like 5-10 years ago, I thought it was the future, but I guess it's happening right now. Now the plant can manipulate the different elements of the greenhouse, of the vertical farms, so that itself can provide optimal climate. I want to remind the attendees that we have a Q&A session in a bit. And if you can direct the questions for each of the panelists, that would be great. I want to talk a bit about Agritecture Designer as well. We understand here in Agritecture, we understand the importance of the energy use and in the feasibility of agricultural projects. This aspect is a key component of Agritecture Designer, which is a tool that allows the estimation of the use of resources, so energy, water, CO2, and consumables, either of a greenhouse or on a vertical farm. And it's based, this model is based on climatic conditions that you select, crops, and types of growth systems. These results are coupled with a financial model that can estimate operational costs, capital costs, and give you an idea of the return of investment of the project. So it answers several questions, such as, what is the most suitable crop to grow? What's the cost of implementing artificial lighting in a greenhouse? And what is the scale of production based on a budget? So if you want to learn more about the Agritecture Designer, just go to design.agritecture.com. And speaking of questions, we will continue with the Q&A session. So let me see if I can, oh, maybe I can stop sharing screen. And then we can go to see some of the questions that Brianna presented. Let's see. So we have questions. Question from for everyone is this one. So basically is how can startups work with efficient light going at a garage or your house? So we're talking about really small productions. Are there some recommendations? Where can you start to develop this type? How can you integrate this type of technologies in a really, really small scale?
Well, so perhaps I can add something here. We started in a bunker, and this was never profitable. So yeah, I think it's a question about the minimum size of the vertical farm that you need to build. And we figured out, for the context of Switzerland, you need at least 600 square meters of grow space. Grow space is not the area, but the accumulated space of layers to be profitable for high margin products such as herbs. So I think this is a very good question, actually. What is the minimum size of a vertical farm for a specific context to be profitable for which products? To give you some insight here, what we are planning right now, we are actually planning the 10x vertical farm, which will be significantly larger than what we built right with the pilot farm. So there we also want to tackle low margin products. So as soon as you go to low margin products, such as leafy greens in Switzerland, you will have to really grow big and go big, because agriculture itself is something that requires so much resources such as space or water, you can't really think about it in very small cases if you want to have a profitable operation. If you want to do it as a leisure, of course you can do this, but then it will be gardening in effect, or in terms of the wording that you use, not farming. So farming is always commercially oriented.
I would say that the garage question is hobby, I would expect, but that could grow into a production system. The first thing I would look to is don't overlight. You have to read into what you're trying to grow and see its minimum requirements, and save your energy, start small. You can add to it as you go in terms of additional lighting requirements. But then in a garage, it's uninsulated probably. It has no heating and cooling capabilities. So you have to add that somehow. And the question is, if you're in Tucson and you're in the south facing garage, it will be 50 degrees Celsius in there in midday. Do you really want to try to cool that? That becomes a challenge. So pick your locations carefully. And I always say start small prior to profitability to gain experience in working in the production system. Understand the hydroponics as best that you can. Become comfortable that you can grow a crop under semi-ideal conditions. And your first design is not going to be ideal conditions, that's for sure. But it's a place to start.
I would say something about this that I almost don't agree with this, but it depends on the scale, because I think what needs to be clear from starting point for a grower is that the investment at the beginning needs to be at least such an amount of money, because then it's like it's fake economy, it's fake savings. Like he can invest in something like half light, half equipment, and then instead of buying the right one up front, and then like adding the other half is going to be more expensive, because you probably have like a discount on buying like 10, like let's say 100 lights, and now you need to compare to like 1,000 lights. 1,000 lights would be way cheaper than 100 lights, and it's true for all equipment, because then you have to do like, let's say I'm talking about like a big facility that needs engineering for the HVAC system, for example, or your CO2 plumbing, or all the installation. If you overlook the optimal conditions of your crop and you try to get there slowly, step by step, you might lose a lot of money in this trail. Yeah. Of course, it depends on the scale. Like in a garage, it might not be relevant what I'm saying, but in a commercial production, it's very often people like try to grow with, because they don't have the budget, and that's totally a legit concern. But then they need to redefine their goal. It's like, what can you reach with this amount of money? That needs to take a lot of time and education, rather than trying to get there and make like 3 years of mistakes and don't understanding why. Like I think that's a mistake to avoid.
So now we have, thank you very much for the answers. And now we have another question, and we're talking about reuse of heat. So is it possible to reuse the heat from container farms to heat greenhouses?
We can reuse heat actively. So you just need an elaborated climate control system, but we don't reuse it to heat up greenhouses. We use it to heat up neighboring spaces, office spaces, for instance. So it depends very much, but also in summer, then in Switzerland, it's warm enough. So you will have to add cooling parts at some point. So it depends very much on the context, I would say. It's hard to generalize it, but the technology is available and it's here, and you you can apply it, but it needs a lot of design and engineering to do so.
I would believe that the most cost-effective thing to do is what you just said, Mark, is use it internally at your facility as best you can, and not have to count on giving it off to another facility like a greenhouse adjacent. I mean, there is the other approach in cold locations, using waste heat or reject heat from power plants or from businesses, where hot water can be brought to the greenhouse, for example, for heating in the winter and offset heating energy costs. That still requires a pretty good synergy or a relationship developed between the heat provider and the greenhouse operation. And I don't think a vertical farm would want to connect with a waste heat person. They don't need the heat for sure.
Thank you very much for the answer. I had a question about LED lighting here. So this is an important question that we're talking about, energy consumption of LED lights. Can you decrease the energy consumption while keeping the same amount of radiation, the same amount of ppfd?
In a greenhouse, you like different strategies with a shade cloth. So depending on what is your ppfd target, if you have like an over intensity coming from the sun, you need to reduce that intensity to get it at the canopy. But I would like to emphasize the fact that it's probably smarter to use like what we call a daily light integral strategy rather than the ppfd. Especially that there are like low light crops such as leafy greens like saturate to high intensity of light. But in terms of DLI, there are like a lot of research that shows that you can adapt your intensity during the day as long as you reach the DLI target. And that can make like savings also in indoor farming. You can avoid the peak rates, like the peak charge of your electricity company. You can try to lower the intensity of your artificial lighting during the peak rate where it's the most expensive, and higher a little bit the intensity during when it's cheaper. And you still reach the same amount of daily light integral. So I personally try to build some kind of algorithm, and I strongly believe in the DLI sequence of operation, but sometimes it's not as, it requires a little bit more equipment and upfront costs to do so. So I hope I answer somehow the question. I'm not sure.
Yeah, I have another question that it's relevant both for vertical farms and for greenhouses, and we're talking about control of high humidity environments, high humidity, high temperature. So yeah, the question is directed towards greenhouses. What is the best way to get rid of high humidity in greenhouses at areas that are close to the ocean? So I suspect high humidity conditions.
That's a tough one. Because normally the assumption is that the humidity is higher inside the greenhouse than it is outside because of all the plant transpiration. So you exchange outside air with inside air, and therefore you lower the relative humidity. I guess maybe the only saving grace here is to have you look into vapor pressure deficit, VPD, as the true measure of the correct or the proper environment for a plant. And if you can maintain that VPD, you change VPD by changing the temperature and the relative humidity. And there are charts that you can look at that when you have one and the other, you can read your vapor pressure deficit. And it's known numbers for different plants, what that should be, VPD, and therefore you target that, which means that you can get a same VPD at a lower temperature and lower humidity or a higher temperature and a higher humidity if you adjust them properly. So you can't take the moisture out of the air, but can you cool it or heat it? And it doesn't seem possible or appropriate that you should be heating the air, but you reduce your ventilation and the temperature will rise, the relative humidity will drop, and the VPD will go up. And that will help transpiration and keep the plant actively growing with the stomates open on the leaves. A little bit complex there, but that will become a strategy in the future that will be well understood as we go on.
Yeah, so this is an important question for, yeah, let's say tropical conditions. So what about implementing a semi-closed greenhouse strategy? And this, I think it probably brings together the, let's say, control strategies for vertical farming and from greenhouses as well. So the reason you want to control high humidity is, yeah, basically to avoid pest or hospitable conditions for development of fungi, of diseases, right? So if you manage to understand what is the threshold at which this happens, and you apply, or let's say when you have the relative humidity at that point, you close the greenhouse, you dehumidify, and then you avoid that risk. And then after that, you continue with traditional, let's say, control strategies for using external ventilation. Do you think this can be applicable in the future, or is it applicable right now as well in some greenhouses?
Well, technically, it can be done, right? Herve,
Yeah.
please.
Yeah, no, sorry. It's technically can be done. What is the cost of the equipment? Like dehumidifying is very challenging and highly energy demanding. You can have refrigerant dehumidifiers, but if you use like a semi-closed design, it's gonna take, I don't know how many pins per day you need. And then you have like these giant desiccant wheels that you can maybe use for like commercial application. But once again, the upfront cost is, I think, scary for this type of equipment. And I'm sure there is plenty of research about this. It's like, it's a challenge for everyone, even in indoor farming, like dehumidification is your HVAC system is not built for plants. Like it's kind of recent development in the HVAC world, having like efficient HVAC system that can dehumidify, condensate the water out of the air. You need to bring it to a very low temperature. It's like an overcooling dehumidifying. So it takes a lot of energy to do that, and still very challenging. So it can be done. I think the semi-closed design for greenhouses seems to be a good step towards improvement of dehumidification. I personally like this design. I don't know what is the upfront cost and how can you make it worth depending on the crop you are growing, where you are growing, and your market around you.
Mark, do you have any comments on high humidity
Yes.
vertical farms?
Tropics. So we were thinking about the tropics once on islands. I especially am tempted by remote regions like islands, which have to import a lot of products. And the design that we came out with, we didn't fully calculated it, but the design that we came out with was a design that would be underwater floating islands of vertical farms. So you would have an environment which is cooler than itself, and you wouldn't tackle the very fruitful arable land, which is usually in the tropical available. So you would actually just expand horizontally into the water, and usually these cities are placed on the coastlines anyway. So this could be, for instance, for a place like San Andres in Colombia. Could be interesting, but we're still based in continental Europe right now. But I would love to create that once, perhaps. Yeah, but that's very far away. Thank you.
That's for the future. Well, Hervé, do you want to comment on that?
Yeah, I just wanted to add something like that's where having a sealed environment such as indoor farming can make sense. If your outdoor conditions are always too humid, maybe having a closed environment makes sense, because controlling the humidity inside the closed environment is way easier. And once you remove the humidity of your outside environment, then you have the plant transpiration only to deal with. It can be a lot of dehumidification, but in a tropical conditions, you have to deal with the outside conditions and the plant transpiration. So that's where I think it can make sense.
Sounds good. Unfortunately, we're running out of time. So all the other questions, I think Brianna can write it on the chat, but I think we can answer it on the Agritecture newsletter. So please register. And then I want to thank the presenters for sharing their insights on this topic. Yeah, we will continue to have these webinars focus on different CA topics. So be sure to visit Agritecture's website for more information. This coming Friday, we have a webinar with BIOS Lighting if you want to learn more about the current lighting solutions. And yeah, so thank you very much for attending, and see you in the next webinar.
Thank you very much for having us.
Thank you. That was a pleasure. Thank you.
Thank you.
Bye-bye.
Bye-bye.
Bye.